Hydraulic and pneumatic systems are the cornerstones of power transmission and automation. Functional safety plays a critical role in ensuring these systems operate safely. In this presentation, we will examine the safety principles that must be considered in the design and operation of these systems. The presentation begins with the basics of hydraulic and pneumatic systems, examining their components, a comparison of the systems, and international standards. First, how hydraulic systems work and the basic principles they employ are explored. Then, the fundamentals of pneumatic systems and the differences between these two systems are studied. We will detail the safety rules for hydraulic and pneumatic systems according to ISO 4413 and ISO 4414 standards and how these rules are applied. At the end of the presentation, we will examine an example of a monitored and redundant hydraulic control circuit designed for a downward stroke press brake. Hydraulic systems produce force and movement by using pressurized fluid in a closed circuit. According to Pascal's principle, pressure applied to a fluid spreads equally in all directions. This allows a small input force to generate a large output force. The fluids used in hydraulic systems are typically incompressible, enabling these systems to operate with high efficiency. The fluid in the storage tank passes through filters to the hydraulic pump. The pump pressurizes the fluid and sends it to the control valves. The valves determine the direction of the fluid and transfer it to the cylinder, producing mechanical movement. Hydraulic systems consist of several key components. The storage tank stores the fluid and delivers it to the hydraulic pump. The pump pressurizes the fluid and transfers it to cylinders and pistons via control valves. Pressure regulators control system pressure for safe operation, while filters keep the fluid clean, extending the system's lifespan. Pneumatic systems produce force and movement using compressed air or gas. The pressure in these systems is generally lower compared to hydraulic systems, but they offer faster response times. The greatest advantage of pneumatic systems is that air is readily available, making installation costs lower. They are widely used in industries, such as automation and assembly lines. The main differences between hydraulic and pneumatic systems are the power sources used and the force levels achieved. Hydraulic systems provide high force using incompressible fluid and offer precise control. However, they have slower response times. Pneumatic systems, on the other hand, provide lower force, but offer fast response times and lower costs due to the compressibility of air. Each system has its own advantages and disadvantages and should be chosen based on the application. ISO 4413 and ISO 4414 are international standards developed to ensure safety in fluid power systems. ISO 4413 standard defines safety rules for hydraulic fluid power systems, and these rules are applied during the design, production, installation, and maintenance of the systems. ISO 4414 standard is a similar safety standard for pneumatic systems, outlining the safety principles to be applied during the design, production, installation, and modification stages of these systems. Both standards incorporate the safety principles outlined in ISO 12100 standard, which can be applied to machinery. These standards are focused on safety and aim to prevent potential risks in the systems. ISO 4413 is an international standard that ensures the safe and efficient operation of hydraulic systems. Starting from the design phase, it identifies potential hazards during manufacturing, installation, and maintenance, and outlines the safety precautions to eliminate these hazards. ISO 4414 is a standard developed to ensure safety in pneumatic systems. This standard outlines the safety measures required to prevent pressure leaks and sudden pressure changes in the system. In this hydraulic system circuit, the movement of the cylinders is controlled by directional control valves, while hydraulic check valves prevent potential drops. Safety valves, combined with monitoring functions, protect the system from overpressure or possible hazards. Cylinder protection valves are adjusted and sealed to prevent the system from exceeding maximum pressure levels, which is an important safety precaution. Both the directional and safety valves are of a monitored design, meaning their performance is constantly checked. Any failure is detected immediately, and the system is safely shut down. Although each cylinder is independently controlled, the system includes a redundant safety structure. This means that, even if one component fails, other safety elements ensure the system continues to operate safely. ISO 4413 and ISO 4414 are two important international standards aimed at ensuring safety in fluid power systems. By establishing comprehensive rules for the safe design, assembly, and maintenance of systems, they set globally recognized safety norms. Systems designed by ISO 4413 and ISO 4414 are not only safer, but also more efficient and durable. These standards contribute to both worker safety by preventing accidents and to the improvement of production processes. Thank you for listening. Please contact us for your questions.